Good day, and welcome to CFE Media's Virtual Training Week. For this session on how all-in-one automation platforms simplify machine building and increase flexibility, we'll be joined by Dan Sage, Business Development Manager, Drives and Automation for SEW Eurodrive USA. I'm Kevin Parker, an editor with CFE Media and Technology. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be issued to each participant. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. The benefits of using a single source for automation components, control architecture, and software are many, including increased flexibility, simplified time-saving machine design, and a wider range of available compatible drive technology. Typical challenges in machine design include compatibility and integration issues associated with electronic controls, drives, and software sourced from a variety of vendors. Using a single source for machine automation design can solve many design, startup, and commissioning problems. You see before you a list of the learning objectives for today's session. Additional resources can be viewed and downloaded on the left side of the screen below the session's agenda. If you would like to take notes within the session, click on the left panel labeled Notes to do so. Please remember that this session will be made live at 10 a.m. Central, 11 a.m. Eastern. Question and answer period with industry experts starts approximately at 10:45 a.m. Central, 11:45 a.m. Eastern, or immediately after the presentation ends if it runs a little longer than 45 minutes. Answers will be archived with the session. You can see the Q&A details in the Meetings tab on the left side of the screen. Zoom invite details can be found in the Additional Resources tab under Q&A session. Want to take the session again? No problem. This session will be available on demand. If you're experiencing difficulties, please log out and back into the session to continue. Attendees are eligible for 1 PDH credit for this event, airing on October 21st, 2022, and is categorized within the Technical, Health, and Safety, including Core Technology category for RECEP. The event is a live educational session presented on October 21st, 2022, and on demand afterwards. I'd now like to introduce today's presenter, Dan Sage, Business Development Manager, Drives and Automation for SE Eurodrive USA. With more than 30 years of experience in the automation industry, Dan spent the first 15 years on the control side of manufacturing, machine building, and integration, with skill sets ranging from design to commissioning. Over the last 15 years, his primary role has been automation distribution, with a focus on managing sales, automation, and new business development teams. In his current role at SEW Eurodrive, Dan is responsible for developing strategies to expand our current customer base into channel partners and create new partnerships with integrators, machine builders, and OEMs. Dan particularly enjoys listening to customer challenges and wrapping an SEW-based solution around those needs. Dan, welcome to Virtual Training Week, and please go ahead.
Hello, again, my name is Dan Sage, and I'm going to take the next half hour or 35 minutes to share a little bit about an all-in-one automation platform, a little bit about my history. I've spent 30 years in automation with about 50-50 split, half of it actually doing design, build, commissioning, programming, things like that for end users and OEMs or custom OEMs. And then another half of my career actually on the distribution side of business, both in sales, management, technical leads, new business development, a variety of different roles there. So what we're going to, again, share today is a little bit about an all-in-one automation platform. Some of the key things around an all-in-one platform is, and the benefits of that is really getting into the simplification of machine build, increase in design flexibility, building blocks for the future. Benefits of a strong engineering platform and what you can do, not just a traditional ladder logic design, but advantages of a new all-in-one platform. Some of the control techniques or technologies, drive technologies that go along with those controls. Maybe a starter set for a machine. If you look online and take a look at, just search the word starter set, you can see complete packages of all the components that bring value into an all-in-one automation platform. And some of the key things that are really important into this is to help reduce installation, commissioning, maintenance. And one thing I don't have marked down here is cost. If we can reduce costs, we can bring up value. I'm going to take a minute here and just share a little bit about the components and what we talk about in an all-in-one controls or automation platform. It's not the exterior, it's not an enclosure, it's not a lot of the little elements that bring something to make it an all-in-one automation platform, but it's really the key components. I'm going to take a minute here, and hopefully this is a little less painful than it has been in the past, but I'm going to grab the pointer just so we can kind of focus in some areas. So we're going to talk about a couple things here: centralized, decentralized. That'll make sense in a little bit. The hardware and elements of that hardware and stuff. So we're going to start off with what everyone knows here. You can't see, it's kind of shaded out, but we've got an enclosure here that is a bunch of different elements, disconnects and things like that. But we're going to talk a little bit about the motion controller that we're seeing here. And on the end here, a little PLC controller. So the PLC would be more of the supervisory control. And the motion controller is really going to be that secondary that's telling other elements of the system how to operate, when to operate, and what to do from there. We will talk a little bit down the road about modular program and how those work in relation to these controllers. So the next piece of the pie would be your interface, your upper interface, the things that's showing you what's going on, how it's going, any data that you're collecting and you want to display. If you've got an error or maintenance, the action that's actually happening out there. The next piece we're going to talk a little bit about that would tie in is centralized control. These elements here that are getting signals back to a panel. This controller makes the decisions and then tells us what to do. And you can see that in here in a few different spots, different sizes, different elements on a conveyor, an assembly, a test, any of those type of things. And then the other elements out here are components that may or may not get a command from a centralized control, or they may be out here decentralized with actually a controller right on the component. So the advantage is there. If we had controls for every element out here in an enclosure, this enclosure may not fit in this area. And if this is the area we have to work with, we're in trouble. In a lot of cases, when you have everything that's centralized, the controller could be 3-4 times the size, or excuse me, the enclosure could be 3 or 4 times the size that we have here. What we're talking about is now having other elements, other factors, larger disconnects. There could be, heat dissipation and other things that may go along because you get all these controls and everything are creating other elements in an environment. Depending where that environment goes, you don't want to have a lot of heat. If you're in a food environment or a cooler or something like that, or freezer, that's all about energy. Increasing energy, controlling energy and stuff. So if we can eliminate and reduce that that control size, that cabinet size, by a decentralized application, that also may give us an area to add another conveyor, another piece of equipment that can help in the process. So, there's key elements that really make it a big advantage if you're looking at a all-in-one solution, and you can both do a centralized and decentralized controls. Our next piece we're going to talk a little bit about is really the providers that we service and we talk about that and the advantages of these controls. And I'll take this pointer away, or attempt to. There we go. So when we're talking about who the providers are, most commonly known as your traditional OEM. It's the original equipment manufacturer. They make the same thing in and out over and over for maybe, 2, 3, 4 years. Maybe they'll have a second generation. Maybe they have different sizes of that piece of equipment. We'll say a lens polishing machine. Maybe they make, 100 of them a year, but they make 3 different sizes, 300 different pieces for the year, but they're consistent. Same controls. Once it's designed, built, they do it over and over again, maybe until those controls are no longer supported or whatever. The next is actually a custom OEM. Custom OEMs making a unique piece of equipment. It's put into manufacturing. It may do test, assembly, some other element, moving, just conveying, pieces, but it's got a special application. It's done traditionally for an end user manufacturer, and they don't make traditionally multiples of them. It's not necessarily a product that they produce themselves. It's really custom OEM is really someone that's making something for a end user or manufacturer. Next piece we'll talk about, or next person we'll talk about, or group, is integrators. The integrators usually take existing equipment, maybe a little bit of custom manufactured equipment, some key software, and stitch those together traditionally for a process that actually create a process or to highlight or modify a process. But they're the ones that take key components, take them all, put them together, bundle them, and get them into an end user's hand. The fourth one is a builder, a straight builder, contract manufacturer. They don't do a lot of design, if they do any. They usually take an existing design that's created or whatever, and strictly construct the system. Usually very lean, not high profit margin type applications, but they've got this skill set. They build them over and over again. They come up with a process. They work with an end user or an OEM to manufacture these for the OEM and produce X amount per month, per year, and help with the delivery. Music helps they have buying power, and there's certain advantages there. All 4 of these work really for one area, right? They're really trying to help support end users, the people that got to run, maintain, and utilize this equipment day in and day out, year after year. So that's kind of the people that we'll be talking about, or the people that use these systems and everything. Next thing we're going to do is talk about a little bit about key advantages. What are some of the key advantages of having an all-in-one system? And these are things that people sometimes don't traditionally think about, but they're all about bringing value. The first couple pieces are really, you got a single supplier, one PO, accounting, all the other office elements, or people within an organization. This is about reducing costs. Transactional costs is very expensive. People don't think about it, but they are, if for every PO you cut, that is, it's somewhere between $100 and $250 a PO. So, if you buy or cut 100 POs to build a piece of equipment, just figure out that extra cost. So if we can reduce that cost by an all-in-one system, it really, impacts the bottom line and brings value to our end users. Simplify the shipping, getting deliveries all at one time, everything shipping out at once. Both parties win there. It also reduces the chance of components getting lost. If you can get one crate with 15 items in it that are all going together, instead of those items coming from 15 different people, we won't even know how they'll work together. And on top of that, that person in receiving and in shipping needs to touch each one of those items. It gets moved, it gets stored over another area until all the items are good. If they're all packaged together, if they're all coming together, if that can be done, that really helps and brings value too. I mean, the chances of things getting lost, damaged, all those elements really helps exactly here, the end user, the final customer. Things are usually traditionally able to ship on time. Failures, damages, all those things are reduced. So the key advantages, a lot of these things, well, they work together, actually are more maintenance friendly, failure friendly. When we talk failure friendly, easy to replace, they're identified, systems talk to each other. If there's a failure, something going on with the motor can actually communicate back to that control system, because basically they're related. They understand each other, and you can be in a more proactive instead of reactive environment. So another key advantage of an all-in-one automation system. Single control platform, same software for everybody, people that are doing the programming and developing, to the people that have to work on this equipment afterwards. And that's a lot of times in that second phase, people talk about developing and building a piece of equipment, but sometimes maintenance is overlooked, and the serviceability and the ease of using the components that are put together get difficult for that end. If we're a little bit more proactive and thinking about how those components will work together, it's really going to save everybody a lot of money, be more cost effective, and again, bring value. So reduce engineering time. There's a couple things we can talk about here. I'll try to keep this short and sweet because we'll talk about it a couple times. But the fact of the matter is, when you're selecting components in an all-in-one automation system, you really are bringing other values in there. In today's world, with the modular design, modular programming, the consistency there, it's going to reduce engineering. And I've spoke to a lot of people about this in the past. You look at a systems that are $100,000 or more, custom systems, integrated systems. A lot of times, the hardware is a small percent of an overall system, anywhere from 15 to, we'll say, 22, 23%. A lot of times, people are working really hard with multiple people to try to save 3 to 5% on hardware, where the biggest savings really is on the engineering side. Just think about it. If it's an 80-20 rule, 20% is the cost of the hardware, 80% is all this design and labor and programming and all the other things that take place. Or would you rather get your 5% back from hardware or engineering? And with the modular software now, and the elements you can do and the way you can stack those together, there's your big savings. There's where you can really reduce cost and bring value. And you can also do a lot of other things with that. Think about ease of expandability. When you got something that's already working well together and you need to bring another conveyor on and you add another motor and a drive, and they very quickly integrate and communicate with the controls that it's on. Just makes things so much simpler. Again, usually less engineering, and the system's up and going quickly. And that's what we ultimately really want, right? It's about reducing downtime, efficiencies, manufacturing, more components or elements in a certain time period, and that all equals profitability. So, engineering, over engineering, excuse me. You know, if we can increase design flexibility, you can make things a little simpler by plug and play, reducing the startup effort. Like I said before, having a motor easily communicate with a drive, configured quickly and up and going. That's the way we want to operate, and that's what happens when you're looking at an all-in-one platform. So, um, reduce the engineering time. We talked a little bit about that. Really, it's all around that programming design a little bit, using those same components. There's a familiarity piece of this. You get comfortable and you understand and you know what they can do, how to perform. You get this base, even in the design side, you get this base components that you're using. It's very easy to take those templates, plug it into an AutoCAD drawing or um, your drawing package or whatever, and continue to use some of those. We don't need to change everything. A lot of times, even for an end user, they'd be fine with a 1 horse and a 3 horsepower drive. The form, fit, and function is all the same, right? The frame size is the same, and quite frankly, it can help reduce spares and stuff if you look at it like that. So, drive technology, different motors, technology gearing, reducing energy, reducing sound. There's a lot of advantages that we can talk about around, the over-engineering and adding value. If you do the one piece at a time concept, pulling things from different areas, a lot of times what you get is things not necessarily working well together. You may reduce cost, but you're really bringing value. There's an old song that Johnny Cash wrote years ago. It's called One Piece at a Time. He wanted a Cadillac and they couldn't get it. It didn't make sense. So he built it over the period of several years. And this is what he got. Well, he's got a Cadillac, but is it really functional? Is it really going to get everything you need, other than saying that you got this Cadillac? Can you get 60 miles an hour out of this? Does it even run? Who really knows? Definitely a maintenance nightmare. Looks kind of cool. It's good. It's good little fun or whatever. But if we do the same thing, when we're building a piece of equipment, using different components that really aren't meant to be together to try to reduce some cost or whatever, the overall value is really not there. And what the real outcome that we're looking for really doesn't happen. I got a similar little slide here, a little picture of another thing where there's this all-in-one component. It's got extra room in the station wagon, but it's a Rolls Royce. It's got a roof rack. It's got all these cool things that you'd like all in one thing, but really the one little piece of the smaller picture, the only working element is this little, almost like lawnmower type application here, where I don't think that's the real value and really what they were looking for. But I think you get what I'm saying here. When we do the bits and pieces, just don't bring the overall value. If we look at it more like this, a shaft to plug approach, where we're taking and looking here, what's the motor, the gear box or reducer, whatever we need on that motor, the DPI cable, a very smart cable that can tell you the status of things, selecting the right inverter, the motion controller, the controller. And what I don't have here is actually the correct software, right? So, a piece of software that really does more than just writing up a bunch of ladder logic. You can even have that ladder logic kind of bundled together, but it's a little bit harder to use on the maintenance side when they're troubleshooting things. The more modular you can get, the better it is, right? So eliminate all the guesswork, bring value, use all the components that are meant to be pulled together. And if you do that, you're probably going to get something more like this, right? Everything looks good, it works well, it's expandable, it's modern, it's something you want to use. It's maintenance friendly. This is what we're looking for. This is what people are looking for. This is what our customers are looking for. give you a little snapshot of what we're talking about. We talk about, a little bit more realistic pictures of all-in-one components. Here's another snapshot of that controller and um, motion control, drive control, and PLC type application, and in an enclosure. These photos here are snapshots of what we call the decentralized components. So connectorized, easy to wire up, very quick to get up and going, maintenance friendly, good communicating on any key platform, whether it's Ethernet IP or ControlNet or device net, excuse me, I'm going to stay away from that one. But any good communication platform. In a lot of these, some of these on the lower part, that is your drive mechanism. So if that fails, easy to take apart, plug another one on. It recognizes what it is, sends the information right back to the controller. Boom, you are up and going. The nice thing about this thing too is you get into control cabinets in the centralized world. You're talking about other elements. One, the biggest one that comes to my mind is safety, and we get into arc flash and stuff like that, and people suiting up properly. And I know at 1 o'clock in the morning, when the guy's concerned, or the individual is concerned about getting the machine up and going, sometimes as much as you'd like them to be, they're not necessarily concerned about whether they got time to get their proper PPE on. It's not an excuse. It's not acceptable, but it happens. You get in a hurry trying to get that machine up and going, and you may risk some things getting into that enclosure if they're even allowed in. Maybe they're not even certified, so the machine then sits down till the morning when someone can. And a lot of times in a decentralized application, you can disconnect power remotely to that one piece, reconnect or replace the right unit, retie your cables in, turn your power on, it reads, it's configured, and you are up and going. There's some other key elements that are out there. That center picture shows you a little bit better around some more decentralized components that are available. On the left side, we're talking about contactless, energy. We'll talk a little bit about there in another example, but this is another way to work in an all-around platform, but also a safer way. Little things that are just done that really make a big impact and a big difference. So you can see on a tripod over here how things are kind of set up, or this isn't a centralized, but it's all in one. It's configured. This machine was up and running, pretty quickly, where traditionally this would have been weeks. This is probably more so 4 or 5 days. So what are the key things in here that we've talked about, I've spoke about a couple times, is really the modular program and having everything fit in one. Some of these programs go into different elements of controls. We talked about supervisory control and motion control, the controllers or other type of controllers. When you're looking at modulars, there's some different ways or things that can be looked at, or elements. In a drive system, you could have a package, these modular packages that just strictly do positioning. Very quick, simple. There's other things you can do for energy recovery, all-in-one communication. There's elements for specific pieces of equipment, like a stacker crane, right? Where positioning is really important, but anti-sway, anti-slosh, things like that, where it can become a safety issue, but it also affects cycle time. And how do you reduce that cycle time? Well, you can't have that stacker crane just swaying all over the place. I mean, it's not efficient. Well, some of these modular programs give you the ability to do that. Multi-axis control, right? Robotic control, good packages of visualization applications, and a lot of these things too. These modular applications, they're stackable. They can actually work together in a controller. whether you've got to control certain elements in one environment or multiple elements in multiple environments. And here's a sample of, a handful of different modular software packages that all go into a single controller, but here's the different elements that you can see that how they're operated, right? Whether they've got jog functions, reference functions, something that's still binary controlled. Maybe you've got something specific to torque, right, or speed. Using those modular units together, again, reducing time. It's all prepackaged, all ready to go. You set a couple of values. They all work together to make things a lot more efficient. I'm going to take a few minutes. We're going to use this sample because this is an easy one to talk to throughout a handful of different slides going forward. But the complexity of controls and what people want, sometimes it feels and looks very simple, and sometimes it is, but sometimes it's not. A lot of people, really good engineers, controls engineers, are really good at making things look simpler than they really are. And then again, it goes off to a maintenance person, and you get this complex thing that they've only partly been trained on. It's harder to understand. Modular controls, modular systems, modular software, and all in one platform really makes it easier for everybody. But let's just take we got a simple access of just an X and Y that moves up and down, standard, field bus protocol, simple to do. All of a sudden, you're tasked with charging, reducing a cycle time. You got to make some more parts or whatever. A lot of times in an all-in-one control that has some of this modular programming, you may start simple, coordinates, but then need to modify or change or expand or whatever. When the modular control system all in one platform, all of a sudden you're doing interpolations on the axes, right? You're creating these arcs. You're not going up one point, registering you're there, and then over to another point. You're actually creating this nice little arc to get you, to what you need to work on quicker and place it and then pull it and, readjust it or whatever else you may need to do. It's all about time savings and efficiency. Also can reduce wear and tear on your pieces of equipment and just makes things brings a lot more value to the system. In a similar situation here, we're going to, again, use this gantry type application and talk about, a couple of the challenges that kind of go along with any automation system, quite frankly, right? And then how we can handle them. Again, this whole conversation is really about using an all-in-one platform, which traditionally means using a lot of or most of all the components from one manufacturer, right? They all communicate and work best together. Does that mean everything needs to come in? Absolutely not. But, look for someone that is a partner or something that is already predetermined that works well on that platform. And in most cases, it is coming from that one primary supplier. So what type of challenges do we get into? We get into motor dynamics, software integration, coordinated movement, cable runs, remote access, and efficiencies. So we're going to talk a little bit about these challenges, what they are, and things that can be done about it. Start with the motor technology, right? And here's really where things go. Some people, build systems different ways. They start with a controller and design out and identify what they're going to do. Other people design in a fashion that it's mechanical, and they'll select motors and key components there, and then ask the control side to make them work. I wouldn't say that there's a right and wrong way. And some of these good custom OEM, machine builder integrators, things, they're coordinating things, they're meeting, they're on the same page. Again, working with some very common components that they know and know to work well together. But there's so many different options out there on the motor side, gearing side, what the efficiencies you need. These are things where you really should be taking a look and identifying the right things first. This can be your biggest and quickest point of failure. People undersize, don't really understand, have not done the right calculations, and then the inertia is wrong, the load's wrong, um, and that'll affect your whole system. And the most common things is looking for a little way to make it work instead of doing it right the first time. So there's tons of different types of motor technology out there, whether it's single cable, double cable, low inertia, synchronized, asynchronized, just straight induction. Make sure you use the right ratings, the right components, and size things properly for these applications. If it needs a gear reducer, make sure that manufacturer that's supplying that motor can supply that gear reducer. That is pretty critical. You can lose a lot of efficiencies and do a lot of damages when things right here on this motor and gear reducer size is not sized properly. So, software integration. We've talked a little bit about this, or quite a bit about it actually. Key components in the software, right? To really help in an all-in-one automation platform, really does help on integration, on commissioning, and maintenance, and all those elements. When these things are pre-programmed and you can take modules and plug them in, I I remember spending, not days and weeks, but literally months on systems, right? Running code, writing special code, doing, things for robotic applications that were Visual C plus and all this stuff. You can find today in a lot of good manufacturers that are all pre-packaged and ready to go and work well with all the components that they manufacture. So, make sure that they're using the right field bus to communicate with everything. If you got to add another element in there, excuse me, it's a point of failure. There is protocol bridges that can go from one protocol to another, but that's another chance that something's going to fail. It's not as maintenance friendly. If you have to do it, go ahead and do it. But in a lot of cases, an all-in-one platform is going to communicate all in the same field bus across one element to the other. So talk about that robotic control, that limiting functionalities or creating more functionalities. The components in that are chosen in there are gonna help you be more efficient, right? Again, we talked about the pre-programming, the library that's in the program for these components, hardware. Can you pick some similar hardware to make things easier, right? Go up just a fraction of the size for all the components that they're all, one size that will help reduce your spares. Sizing, encoder selection, a larger offering, that's what you want to look for in your components for, going something that's very point to point to something that becomes more of a robotic application. And that's really what we're really building out here, right? So centralized and decentralized. I talked a lot about that earlier. I think it's really important to understand the value of decentralized components, and where they can be used, how to use them. They are the single most maintenance friendly thing that you can have outside of better understanding of the software. But if you want to reduce downtime, keep people safe, this is a great way to do it. It's not the only way to do it, and by means it's not something that can be done every time. but it for wiring efficiencies, reducing installation time, commissioning, troubleshooting. There's so much value in there. Um, you know, they might have an environment where everything has to be in an enclosure or, something like that. And there's reasons, absolutely reasons why. Um, but if you take a look at decentralizing some of those components and making it a little more user friendly, sometimes it's even easier or better for coordinated motion and stuff like that. But definitely really helps. So there's a real flexible way to change the way you're doing some things and make it easier for everyone. Contactless energy. What we're talking about here is actually having a source. So that's just related to your cell phone. A lot of people now take your cell phone, you put it on a pad, and it's charging and bringing power back into that battery. We're doing this now today out in manufacturing. You see it out with AGVs. They go over to a place, they pull up. Sometimes it's contact, sometimes it's not, but they charge and power up, whether it's a battery or some other type of energy source, and they'll store that energy and use it as it's needed to run and move and communicate. Same thing's going on with gantry units and other ways to transport stuff. You don't necessarily have to have a bunch of cables and wires all in one area. I can think plenty of applications where we had these slip rings and bus docks and stuff where all this high voltage is kind of open to an environment. Someone drops a screwdriver, it gets damaged, and these other things, and there's just straight out safety issues. They wear out easier. You got contactless energy. You're transferring that power through a couple cables into a module and powering up your motors and everything else you need. I mean, some of these things, create power as high as almost 50 kilowatts. So you can generate a lot of energy, put them in a capacitor bank or a battery bank like we were talking about, and be able to run pieces of equipment for hours. The other things we haven't talked much about, what you can do is on regen applications, right? And I think I got a slide here in a minute, but there's a whole other way you can use that, store that. Here we are right here. Yeah. Power loss, or controlling energy, reduce the energy costs through a system. Actually storage on regen, picking the right components, using putting everything back onto a system, through a bus, an all-in-one system. There's different ways, but those pieces can all work together. Will help avoid other failures, right? For through storage or whatever. So if you can just have your system run through a failure for a few minutes to get a controlled shutdown, and you do that with an all-in-one system, it's going to really help both getting the machine started back up, reducing energy, safer, all the elements that are really important for any manufacturer. Future innovation, being more on the proactive and predictive side instead of reactive, through technology, letting your control system know that your motor is starting to see, a bigger demand for energy, or, other components that are out there, identifying, communicating, there's embedded sensors now in motors. There's other elements that are in a system that just allows you to be more proactive, not just for maintenance, but for jam ups or other elements that are out there to avoid even a bigger catastrophe. Man, I really trouble speaking there. But yeah, to avoid a bigger catastrophe out on the line. Any minute that a line is down, you're not producing a product that's scheduled, it's costing money, and we want to avoid that as much as we can. So let's recap a little bit on what the benefits of an all-in-one system really is. Primary components working well together. It's one system, one complete company, one house, ease of support. It's helping reduce the overall cost and bring value. It's a speed from concept to production, and it's reliability. When everything's working together, all these 5 bullets here that we're talking about, I just mentioned, all brings that overall true value, right? So that is it. I appreciate your time. Thank you. And any questions? I'm sure we'll have some time to speak.
Well, thank you as well, Dan, and I am sure that we'll have some time to answer some questions. But for right now, I'll just say thanks for a presentation that included some valuable insights into today's automation markets, and we look forward to speaking with you soon. Question will be answered in a live Q&A on October 21st, 2022 at 10:45 a.m. Central, 11:45 a.m. Eastern. Participate in the live Q&A with your Zoom invite details. These details can also be found in the Additional Resources tab on the left-hand side of the screen.